Example 25-10 is a net present value method with an annuity. So it's just payments year after year. And so this one we have Briggs Excavation Company is planning an investment of $132,000 for a bulldozer, and they're expecting the bulldozer to operate 1,500 hours per year for 5 years. They're going to charge $110 for the work, and the cost to operate it is going to be $28 for the labor, maintenance cost of $8,000, and fuel of $46,000 per hour. And so it wants us to start off by determine the equal annual net cash flows from the bulldozer. So we'll start off with our inflows, and so we're going to operate 1,500 hours during the year, and we're going to charge $110 for it. So that's going to give us revenue of $165,000. Then for our outflows, so we have 1,500 hours of operation. The fuel expense is $46 an hour. The labor expense is $28 an hour. And so that means our total fuel and labor cost, we'll just do our 46 plus 28 and multiply that times our hours, will get us 1,011 or 111,000. And then we have maintenance cost of 8,000 to give us total outflows of 119,000, and the difference between the two will be our net cash flows. Whoops, I missed. There we go. So net annual cash flows of 46,000. Then in part B, it wants us to determine the net present value, assuming the desired rate of return is 10%. So we have annual net cash flows of 46,000, and then the present value factors, we can either go look it up in the table, which no one does ever, or we can use Excel like a normal person to determine our present value rate. So the formula is PV, and then we want to enter our rate, and so the rate is going to be 10%. Number of periods, this is over a 5-year period. And so in this one, when we did this in the past and we used the present value in examples like 4, 5, and 7, what we did is we skipped this payment part to enter in, and then we just went directly to the future value amount. That's because that was the value we're looking at, basically like a lump sum payment in the future. And here this is an annuity, which means we have payments. So here, to get our present value factor, we want to do a negative $1 in the payment section, and then we can just put 0 in for the future value. All right, so that's going to give us 3.719. Now, just in a normal situation, we're going to leave it at that. Because the book wants you to look up a table, that means the book has actually rounded the numbers. So, our present value number actually has a lot of decimals going on to it. And so just to let us match the book number, let's just put a round function on here. So we'll just do round, and we want to round that to 3 digits. So now it looks the same, but when we extend out our formulas, those are all zeros. So technically a less accurate number, but it'll help us match up numbers with the book and with Cengage a little bit easier. All right, and so to come up with our present value of all the net cash flows, now we just multiply our net cash flows times our factor will give us 174,386. Now to get the net present value, we just needed to deduct our original investment of 132,000. So that will give us 42,386 as the net present value of our cash flows. And so the question for part C is, should Briggs invest in the bulldozer? And so what's really nice about net present value is it's really easy to figure out if it's a go or a no-go, and that's just if the number's positive, that means it meets all our criteria, which means it meets our return of 10% because we factor that in. So yes, anytime a net present value number is negative, or I'm sorry, is positive, it's a go. If it's negative, that means it doesn't meet our standards. So you could actually have a negative net present value and still be a profit. If it's negative, that just means that it doesn't meet our return of 10%. So, but in this situation where it's just asking, hey, do we want to do it? Yeah, we have a kind of a hurdle rate or a goal of 10%, and we meet that plus an additional 42,000 essentially. So yes, it's a good deal for part C. We want to go ahead and buy the bulldozer. All right, and so in part D, it says determine the number of operating hours that such net present value vehicle cash flows are not to be invested. Okay, so basically, what we want to do, what is asking is, hey, what basically how many hours, operating hours, will give us a net present value of 0. So it's the minimum operating hours that we can have to still be a good deal. So to do that, the easiest way, and what a really good tool in Excel is the goal seek function. So we're actually going to use that to solve this. So to do this, the easiest way to do this is just go up here to what we did in parts A and B and just copy it and paste it down. So that's going to paste down all our formulas. So if we change our number here, it changes our net present value function. So we could we have 3 options to figure out the answer. We can use algebra and plug in and come up with a formula, or we can sit here and guess and just keep changing this hours of operations till this number gets to 0, or we can use the goal seek function. I like to do things as easy as possible, so let's go ahead and do the goal seek function. So to do that, we want to go up to, I think it's data, and there we go. We'll go to what if analysis, and then we'll click goal seek. So goal seek, what we want to do is we want to take this net present value number, and we want it to go to 0, and we want it to do that by changing our hours of operation. And we just click OK. And perfect. So what that's saying is, hey, if we have 1,189 hours, we'll have a net present value of 0. The book came out with just barely a different answer. That's because of rounding. But if you want to see what the book did, you can kind of see their formula here. So their number actually came to 1,194, so 5 hours difference. And the reason they did that is because it says round all calculations to the nearest whole number, where we have a lot of these numbers are not rounded.